In this tutorial, we will learn how to run counts in R, where counts are sometimes referred to as frequencies. Counts are a type of descriptive statistics, which means that they're also a type of descriptive analytics. And so we can use counts to describe variables that have measurement scales that are nominal or ordinal. So as you can see here, we have the data file that we're going to be working with today, which is called employee_demo. And we have our RStudio interface here. Now we're going to read in this particular data file here today. Again, it's called employee_demo, all lowercase, and this is a comma separated values file or .csv. So I've already saved this to the folder that I'm going to designate as my working directory in a little bit, and that happens to be my H drive R workshop folder. You'll almost certainly have a different location or path where you're going to save this file and then ultimately set that as your working directory later on. So as you can see here in my H drive R workshop folder, this is where I save that data file. All right, so let's go to RStudio. As you can see, we've got our console window here. Let's clear out the contents. Don't need to do this, but sometimes it's nice to start with a blank slate. So I've cleared it out. And now let's open up an R script editor window by going to File, New File, and R script. I'm going to make a note here in the script, and that's going to indicate what the topic of this tutorial is, which is counts, and I'll note that these are also called frequencies in R. So how to compute counts in R. So we will start with setting our working directory, which is going to be the folder where we save that data file. For me, it happens to be, again, my H drive R workshop folder. So to set my working directory, I'm going to use the setwd function, and within quotation marks as the sole parenthetical argument, I know that it's my H drive and my R workshop folder where I save that data file, which is employee_demo that we're going to be working with here today. So I can click run and run that. Alternatively, if you don't remember your path off the top of your head, you can go to Session, Set Working Directory, and Choose Directory. And in this way, using the drop-down menus to set your working directory. As the next step, we're going to read in the data file. And we will use that read.csv function that comes standard with base R, which means we don't need an additional package to install in order to use this function. So what am I going to name this object that we're going to assign this data frame to? Well, let's go ahead and I'm going to call it demo here for demographics because it's this file that we're going to be working here today is going to have employee demographic data. So I'm going to call it demo, D-E-M-O, all lowercase, and I'll use the left-handed arrow operator here to assign the data frame that we're about to read in to this object. So again, we're using the read.csv function from base R, and as a sole parenthetical argument, we're going to type in the exact name of that data file, which here it is employee_demo, all lowercase. I'm going to copy that in. And then I need to also add the .csv extension there so that the read.csv function knows that this is in fact a comma separated values file. Okay, so let's go ahead and run that line of code. As you can see, we get blue text down in our console. It looks like everything worked out pretty well here. So let's take a look at this data frame object. Let's click on it here. And we can see that we have 1, 2, 3, 4, 5 different variables, and we have 30 unique observations or cases, where in this instance, each observation or case represents a unique employee. So each employee has its own row of data here. So we have the unique identifier variable, employee ID. We have a facility variable, education variable, performance, and age. In today's tutorial, we're going to be focusing on just facility and education, as these are nominal and ordinal variables respectively in terms of their measurement scales. And I'll explain a little bit more how we know that in just a second. But because these are nominal and ordinal measurement scale variables, that means that they're going to be amenable to doing counts or frequencies. And so we'll focus on these today. And just remember, it's facility with a capital F and education with a capital E. All right, so the next thing what we'll do is we will compute the counts for the facility variable. Okay, and I'll make a note here that the facility variable has a nominal measurement scale. And so how do we know that? And remember that there's 4 different measurement scales. There's nominal, ordinal, interval, and ratio. And so we're just focusing on nominal and ordinal here today with the counts. Okay, so if we take a look at this variable here, we can see that the facility variable has 3 different levels, okay, or 3 different categories. We have a facility that's located in Portland, so some people have that as their entry for this variable. We have a facility that's located in Beaverton and one that's located in Hillsborough. So we have 3 different categories, but there's really no way to order these 3 categories. And these are discrete categories. They don't have inherent numeric values. And so other than just putting them in alphabetical order, there's no way to say that one has a higher level than the other one. And so for that reason, we would call this a nominal variable. Again, it has no numeric inherent properties, and there's really no way to order Beaverton, Portland, and Hillsborough in a meaningful way here in this context. It's just simply the name of the facility where each person works. So given that, it's appropriate then to run counts or frequencies on this facility variable. Unfortunately, that's very simple to do in R. And one way that we can do it is just using what's called the table function, which can be used to construct 2-way and 3-way tables if you'd like, or we can simply do it with a single variable. We can apply this function in order to just get the counts. All right, so in order to use this table function, within the parentheses, we're just going to enter one argument. And that's going to start with the name of our data frame object, which if you remember, I named our data frame object here, demo, all lowercase. And so here it is. And then followed by the $ operator, and then followed by the exact name of the variable and its facility with a capital F. Okay, so why do we use the $ operator here? Well, we use the $ operator to indicate that this variable belongs to this data frame object. Okay, and so this just tells this function that this variable belongs to this data frame object, so it knows where to look for it. All right, so the next thing that we do is we simply run this function here, and you can see down here in our console, we get our counts. That was quick and easy. So we see that there are 15 employees who work in the Beaverton facility, 5 in Hillsborough, and 10 in Portland. So descriptively, we could say the highest number of employees work in the Beaverton facility location, followed by Portland, and then Hillsborough. All right, so after that, we can move on to compute the counts for the education variable. And I'll make a note here that the education variable has a ordinal measurement scale. So how do we know that? Well, let's take a look at that variable. So as you can see here with education, we have got 3 different levels or categories for this education variable. Okay, so it is categorical. However, you can see that we have high school diploma is one of the education levels someone could attain. Then we have some college. And then the 3rd level is college degree. Well, these are discrete categories, but we can order them, meaning that we can put in ascending order high school diploma, followed by some college, and then a college degree, as this would follow the conventional education trajectory. Okay, and so as you can see, some employees earned a high school diploma, some did some college, and still others earned a full college degree. Okay, so this would be qualified as an ordinal measurement scale. Now, the reason it wouldn't be an interval measurement scale is because we don't necessarily know that there are equal intervals between, let's say, the distance between a high school diploma and some college. And we don't necessarily know if that interval is the same as the distance between some college and a college degree. And so for that reason, it's not going to be an interval measurement scale, and instead it will be a ordinal measurement scale. All right, so that means that, again, we could use the table function. But before we do that, let's actually take a look and let's see whether or not we're going to check here, check if the education variable is a factor ordered variable, or rather, let's call that an ordered factor variable. So remember, there's different variable types in R. We have character, we have numeric and integer, and we have date, and we have factor. So a factor is kind of like a string or a character type of variable, except that we can actually order the levels in it. Okay, and so let's see if there's any inherent levels and ordering within this variable to begin with. So we'll just use what's called the levels function from base R, and we will then type in the name of our data frame object, use the $ operator, and then specify that we wish to look at the education variable here. Okay. All right, so look what we get down here in our console. We get null. So when we run levels, this is telling us that this variable is not an ordered factor variable. Well, to make this more useful for our purposes, because this does have an ordinal measurement scale, we want to actually order the different levels. So we want to make sure that the lowest level in the order would be having earned a high school diploma, and then the next level up would be some college, and the level after that would be a college degree in these data and in this context. Okay, so to do that, we're going to convert the education variable to be an ordered factor variable. Okay, and we're going to use what's called the factor function, all lowercase, which is very appropriately named. And so we're actually going to overwrite in this instance the existing education variable. So let's just copy and paste this chunk here, which is again the name of our data frame, object followed by $ operator followed by education. So we'll paste this here, and to the right of it, we will use the left-handed arrow operator here because we're going to assign the factor, the ordered factor we're going to create here, to this existing variable from this existing data frame object. And in other words, we're going to be overwriting the existing education variable. Okay, so we're going to use, as I mentioned, the factor variable, and it's all lowercase, and it comes from base R. Okay, and as the first argument, we're just going to paste in that exact same data frame object followed by $ operator followed by education variable, as this is the variable that we wish to convert to a factor. Okay, as the second argument, and I'll actually do the second argument on the next line here. Don't need to, but I'll just do it here for space consideration so I don't run out of room here. I'm going to use the ordered equals true argument, which just is simply going to say that we want this not only to convert this variable to a factor, but we also want to make sure it's an ordered factor, which means we're going to put order to the different levels or categories within that variable. Now we're going to add a comma so we can do our third argument here. And this is actually going to be where we set the levels, and it's called levels equals. And then we'll use the C function from base R, which you can think of C standing for combine. And if you've used C before, this function is useful for creating vectors. Okay. And so this is simply where we're going to list the exact variable names, or rather the levels. And so as you can see here, we've got college degree, high school diploma, and some college. Okay. So we just need to put them in the order, in ascending order, the order that we wish them to be in when we create this ordered factor here. Okay. And so I want to make sure that I get the exact names of those levels or of the categories within this existing variable. So I'm just going to paste this, which is our data frame, object name, $ followed by the variable name, into the console command line here and hit return or enter. And so this way I can just see the vector of that variable printed out here. And now I'm just going to grab examples of, well, here's the high school diploma, and it's already in quotation marks here for us, which is what we need. Okay, so that's our first level. Add a comma. Then our second level is going to be some college, so I'm grabbing that here. Paste that there. Add another column, and our third level is going to be a full college degree that someone earned, so copy that. Paste that here. Okay, and so in this ordinal variable here that we're creating, we have 3 levels, because those are the 3 levels that exist already in this variable. We're just adding them, we're just putting them in a particular order. So it'll be high school will be the lowest level, followed by some college, followed by a college degree. Okay, so this is how we specify the factor function in order to convert an existing variable to an ordered factor variable in R. So let's go ahead and run this. All right, so if you look at your data frame object, you really won't see anything that looks different here, except that when we sort, you'll see that now it sorts, and when you sort in ascending order, rather than doing it alphabetically, it's going to do it by levels of the factor variable. Now we can also check to see, I'm going to copy this chunk and just reproduce it down here. We can check to see if we actually did this work by running that levels function again with the same argument as we included above. So if we run that, and now instead of null, remember we got null up here when we ran it previously before we converted it to an ordered factor. Now we see in ascending order, the order that we wanted: high school diploma, some college, and college degree. Okay, so that is good. So now what we're ready to do is we are going to compute the counts finally for the education variable. And we'll just use that table function again as we did before. I'm just going to copy and paste the exact name of our data frame object, $ followed by the education variable with a capital E. That's our sole parenthetical argument. Click run. And now you see that here we have in this table listed, we have high school diploma, some college, and college degree in the order we wanted. If we hadn't have done this originally, if we hadn't have converted that existing or the previous education variable to an ordered factor, these would have been out of order here. Okay, it would have been in alphabetical order where college degree would have come first, and then high school diploma, and then some college. You don't have to do this, but intuitively, because it's an ordinal measurement scale variable, it makes more sense, I think, for ourselves and to an audience who might look at these data if we put them in the correct order. All right, so the next thing that we're going to do is let's create bar charts based on these counts. And so we can actually use what we've already done by creating these tables and use that same code as input to what is called the barplot function from base R. Okay, so we don't need to install a special package to use this. Now, this is not the most sophisticated function that we could use to generate a data visualization like a bar chart or a bar plot. If you were looking for something that's more sophisticated, something that would be more publication ready or report ready, you might use the ggplot2 package and its associated functions, as well as there's some other packages out there that can do some dynamic plotting as well and interactive plotting and do and actually create dashboards. But we'll just do the very simple base R function, as this will at least just help us understand as the analyst what these data look like visually. All right, so as the first argument, I'm just going to go up here and let's start with the facility variable. And so I'm just going to copy this whole table and name of the data frame, $ and facility as the sole parenthetical argument. I'm copying this whole chunk of code here and just pasting it as our argument within the parentheses. So I'm actually nesting a function within a function here, okay? Now, if I run this, you'll see over here in my console window, here I get a very basic, bare bones, not necessarily aesthetically pleasing, but nonetheless a bar chart of the counts that we created, that we computed already from when we ran the table function for that facility variable, except now we see this graphically or pictorially. And so you can see visually that the tallest bar belongs to Beaverton, which we already knew, and then followed by Portland and Hillsborough. Okay, and as you can see, these are just ordered in alphabetical order here by default. All right, so you could stop here, and by all means, you can stop here and just say, this is good enough. This is how I'm going to display these data visually. And if that's the case and you want to export this, you can go to either save this as an image, so as a .png file, or you could save it as a PDF, or you can click here to copy this to a clipboard. You can copy the plot, and then you can then paste it into a Word document or a Google Sheets or some other document you might be working with, or a PowerPoint, for example, okay? But let's say that you're feeling adventurous, and this is completely optional. And if you're not feeling adventurous or you just feel done with this tutorial, then this is as good a time as any to bow out of the tutorial. If not, and you'd like to learn how to make this bar plot a little bit more informative, as well as perhaps a little bit more aesthetically pleasing, we'll add some additional arguments to this existing code here and this existing barplot function. So again, our first argument is simply our table function and the facility variable. Our second argument, let's say that we want to adjust the y-axis limits here. So as you can see, and this is one thing that kind of annoys me with some of these default features of some of these charting or plotting functions, is that the y-axis upper limit does not exceed the level of the tallest bar. In other words, the tallest bar is actually taller than the axis. Well, if we want to change the y-axis limit, we can use the ylim argument. So ylim equals, and then the c function or the combine function, so c, and then we just set as our vector the lower the upper limits for the y-axis. So let's keep the lower limit still at 0. So let's put 0, then comma, and then we need to put in our upper limit. I'm just going to put 20 here. You could play around with this and keep in mind that the size of the axis can actually affect how people interpret this. So just use your best judgment when it comes to deciding on these types of axis limits. So watch what happens if we run this updated version of our bar plot here, or our bar chart. Now you see we've adjusted the y-axis limit. Well, let's add some additional arguments. Let's actually add a meaningful x-axis label here. Okay, so let's call this facility, for example, or we could say facility location if we wanted. And also let's add a y-axis label like counts or frequencies here. Okay, and so to do so, we'll use the xlab argument, which stands for x-axis label. So xlab equals, and then in quotation marks, just put whatever title you want for the x-axis label. I'm just going to call it facility, which happens to be the name of the variable, but you could call it whatever you wanted in those parentheses or in those quotation marks. Next, we're going to do ylab equals as the next argument, and this will change the y-axis label, or add one rather in this case. And so let's go ahead and just call this counts. You could call it frequencies, you could call it whatever you'd like. All right, so now let's run the updated plot. And so now you can see here, we've got X and Y axis labels, a little bit more informative. Well, let's keep on going. Let's also use the call equals, where call stands for color, to change the actual color of these bar charts, or these actual bars here in our bar plot. So we can do call equals, and then in quotation marks, we can actually write out the name of certain colors that exist and are readily available to us when in our R program. Okay, and so I happen to know off the top of my head, there's a color of blue that I really like in R, and it's called Dodger Blue. Okay, it's just Dodger Blue, all lowercase, one word. If I click run and update the plot, now you see the bars are a different color there. Okay. If you want to know how to run additional colors, or want to see all the available text colors that you can use, if you just run colors, the name of this function, okay, and nothing in the parentheses, just click run, you'll get a very long list of 657 different names. And so, for example, let's say we want to change it to Honeydew 1. I'm not sure what that color will look like, but let's just replace Dodger Blue with Honeydew 1. Click run. Okay, well, that's Honeydew 1 right there. It's a light kind of seafoam green there. Okay, and so you can play around with this if you'd like to, but you don't need to. So I'm just going to change this back to Dodger Blue. And I'm going to add in, and it will actually, rather than adding in another argument, one thing you might notice here, and I'll just rerun this so that it's Dodger Blue, is we don't, by default, a lot of the functions that do bar charts in R don't add in the horizontal line that often we would see at the limit, the lower limit of our y-axis. So typically we'd see these bars resting on a solid line here that's horizontal. And if you don't have that, it looks fine, I think. But sometimes it might look like these bars are floating a little bit. If you want to add that lower line there, it's actually pretty simple. You just add a separate function. After you run your bar plot function, you run the AB line function, and then do h equals 0 for horizontal equals 0, which means that it'll just be set at the 0 point on our y-axis, and it'll be a horizontal line. So h equals 0, ab line, and if we run that, that just adds that to our existing plot there. If you wanted to export this, again, you could go to export, save it as an image, a PDF, or copy it to a clipboard. All right, so I'm going to copy this, paste this below, and just show you really quickly how we could do the same thing with the education variable. Okay, so I'm just going to swap out education, facility with education here. I'm going to, the x-axis label will need to be, let's call it education level perhaps. We'll keep it that y-axis label the same, it's counts, and let's just do orange here, the color orange, a very basic orange, and we'll keep the AB line at 0 here, at y equals 0. All right, so let's run all that. Okay, and so here's our education level plot here, the plot of the counts or the frequencies. As you can see, we've got the 3 different levels here ordered correctly. If we hadn't have done this, they'd probably be in a different order. So it goes from high school diploma to some college to college degree. And I think this is especially important to make sure we do that factor conversion, the ordered factor conversion we did up here, in order to make this plot more aesthetically pleasing and meaningful. Okay, because this is an ordinal measurement scale variable as we determined. All right. So that's how you run counts or frequencies in R and how to create bar charts with them, as well as you got a little bonus feature, which is how to create an ordered or convert a variable to an ordered factor variable. So this wraps up the tutorial.